So here in RTD is connected in a bridge, Wheatstone bridge as shown below. So the internal resistance of the galvanometer is 25 ohms and the deflection sensitivity is 2 mm per milliampere. So if 1 milliampere current flows, the deflection will be 2 mm. So what is the deflection when the temperature of RTD is 50 degrees centigrade? So you can clearly see for 50 degrees centigrade the bridge is not balanced. Clearly it is unbalanced. So whenever the bridge is unbalanced, we have the current flowing through the galvanometer and hence the deflection. So we need to calculate what will be the deflection in mm when the RTD is exposed to 50 degrees centigrade. So at 50 degrees centigrade, what is the resistance of RTD, which comes out as 100 to 1 plus 0.0039 into 50, so which is 119.5 ohms. So this is the new value of resistance, 100 and so here the value of resistance is 119.5 ohms. So you can clearly see that bridge is not balanced, so opposite arms are not equal, so hence there is a deflection. So we need to calculate what is the equivalent current through the galvanometer. So here we need to simplify the circuit using Thevenin's voltage and equivalent resistance, so which is nothing but current through the galvanometer is nothing but V Thevenin's by R Thevenin's plus the galvanometer resistance. So we need to calculate the Thevenin voltage and the Thevenin's resistance. So from the Wheatstone bridge, we know the Thevenin's voltage is nothing but the applied voltage 12 into change in resistance, which is 119.5 minus 100 divided by 4 times 100. So this gives me the equivalent Thevenin's equivalent representation of the bridge, which comes as 0.58 volts. And the current through the galvanometer we can calculate as 0.58 divided by 104.4. Here the 104.4 is calculated as the Thevenin's resistance, which is, we can see from the galvanometer end, when I see it from the galvanometer end, I have, so to calculate Thevenin's we need to short the supply voltage. So here the equivalent circuit looks something like this. So we have 100 ohm and RTD resistance, and you have 100 ohms here and 100 ohms here. So this is 100 ohms, this is 100 ohms, and all are 100 ohms as you can see. So this, when I see it from here, from the galvanometer end, what I see is, because to calculate RTH I need to short the supply voltage. So I see 100 ohms and RTD resistance in parallel, and another 100 ohms and 100 ohms in parallel. So if I add these two, I get the total resistance when seen from the galvanometer end, which is 104.4 ohms. So here now I know the RTH, VTH and the resistance of galvanometer. I can calculate the current through the galvanometer, so which comes as 4.48 milliamperes. So the deflection is nothing but the sensitivity into the current, so which is 2 mm per milliampere into 4.48 milliamperes, which comes as 8.96 millimeters. So the answer is 8.96 millimeters.